research grant, travel grant, as well as postdoctoral fellowship grant, and travel to various countries like Belgium, Germany, Netherlands, and US. He's having more than 15 plus years of experience in the teaching as well as in the research. He has received more than 6 research projects from the organizations like ICMR, SERP, TST, TIDE, with worth of 1.78 crores. He has published 2 books as well as published more than 60 plus journal articles and conference proceedings as well as 1 book chapters. He acted as a chairperson, delivered special lectures in more workshops and faculty development program STTPs in the topic of machine learning in neuroimaging, artificial intelligence, medical imaging, neuroinformatics, fMRI data analysis. He also had distinguished alumni award in 2022 from Madras Institute of Technology, Anna University. His key research interest includes biomedical signal and image processing, biomedical instrumentation, computational neuroscience, developmental psychology, neuroinformatics, machine learning, and composite science. I hope this session is going to be a great session for us, and I request our resource person to handle the session. Please.
Sir, you are muted, please.
Dear participants, kindly hold on. The speaker will join soon.
Sure, sir. Sure.
Shall I start, Dr. Vivek?
Yes, sir.
Yeah. Good evening, all. Myself, Dr. Jack, serving as an associate professor in the School of Biomedical Engineering, IIT BHM. And also, I'm leading computational neuroscience and biology lab in the School of Biomedical Engineering, IIT BHU Varanasi. So, our school in IIT BHU has 4 programs. One is like a BTech in Biomedical Engineering, 4 years course, and then we have a IDD, Integrated Dual Degree course. There is 5 years course, BTech plus MTech we provide. And then we have an MTech course, Biomedical Engineering. And also we have another MTech course, Medical Devices. And also we have a dedicated PhD program. So if someone has a great score and would like to pursue master's or PhD in biomedical engineering, you can always apply. Usually 2 times in a year we will advertise. One is in the month of October and another one is in the month of April. And our school focus on 3 areas. One is bioinstrumentation, another one is biomechanics, and also biomaterials. So in the case of bioinstrumentation, we have 3 faculties. We focus on developing brain-computer interface, artificial limbs, and also sensor fabrication, sensor design. virtual reality based experiments, and also we conduct EEG based experiments like biometric sleep EEG, and we also study the brain structure and function, like for different disease conditions like epilepsy, seizure, etc. And also this group focus on processing the MRI data, specifically on different disease conditions, brain tumors or neurodevelopmental disorders. And then we have a biomechanics group that is more focused on um, cardiovascular biomechanics and also motion detection. So these are the areas the biomechanics group actually focus on. And also we have a biomaterial group. So this group basically focus on designing the drugs and in vivo, in vitro experiments and animal models, tissue models, and also lab on chip experiments like mimicking the tissues through artificial gels or hydrogels or materials, and also nanomedicine based experiments. These faculties does. So we are actually around 11 faculties, 6 from engineering background and 5 from science background. So my lab, computational neuroscience and biology lab, mainly focus on studying the structure and function of the brain. So we do different experiments through EEG uh, to study the brain, like the uniqueness of the brain, like biometric, and also seizure patterns in epileptic patients, and also we do some experiment on sleep, how actually a human brain behaves during the sleep and sleep disorders. And we do also some computational biology experiments for how to identify the targets using transcriptomic data, and also drug repurposing through computational models, and to study the ultimate properties of the drugs. And also we do some MRI experiments also. So one of the study we conduct in our lab is EEG-based biometric authentication and identification. So in this discussion, we'll be discussing about what is then biometric, what are the methods of conventional methods of biometric, what are their disadvantages, so why we need to actually go for EEG-based biometric, and what are the basics, hardware required to conduct the study. So how we can actually conduct the study during the resting state, or we need to stimulate the human brain, and then we need to actually record. So once we actually recorded the EEG signals, what are the signal processing methods? It may be with a lot of noise, how to remove the noise, and how to identify the unique patterns of each subject, and how to automate this process by using AI algorithms, AML or DL algorithms. And what are the challenges in making this in real time, or what is actually authentication and identification. So how to actually make it into real-time applications, maybe defense applications, or maybe actually video game applications where we can actually deploy. If we are actually deploying in such kind of environment, what kind of practical challenges and future directions. And also I'll be explaining about some experiment we conduct in our lab, and what kind of performance we achieved, and what is our actually future focus. So we maybe actually came across this word biometrics. So it is the use of physiological or behavioral traits to verify or identify an actually a person. So there are actually different methods in order to actually use the biometrics. So we would have been come across the physiological traits like a fingerprint, to a face identification, or an actually an iris. So in the case of fingerprint, it can be actually easily mimicked. So I have actually seen in our department, we have biometrics for the students. So as I said earlier, we have actually 5 labs in biomaterials. What these students does is, so they will actually print these fingerprints by using these actually biomaterials, and they will actually give to their actually fellow students. So even though they are not coming to the department or actually school, so they use these biomaterial based fabricated fingerprints to make the actually attendance. So similarly, we can actually use the facial fabricated images in order to actually easily authenticate or actually vulnerable. So this is actually spoofing and replication of prints or actually photos, maybe actually degrade the performance of our actually system. So also if your actually hand is actually wet or actually your fingers are actually wet or actually varying lightning conditions, this actually performance of these models may actually deteriorate. So in order to actually overcome these challenges, we can actually use the cognitive-based biometrics. So we can actually use different modalities like actually blood volume pulse signals and electrodermal activity signals, that is actually the skin conductance, or actually electromyography signals, or actually electrocardiogram signals from the heart, or an actually an EEG signals in order to actually authenticate. Or even we can actually combine different modalities, that multimodal signals like maybe ECG and EEG, we can actually combine and build an actually an biometric model. So this maybe actually leads to higher resilience to spoofing and adaptive to user state. So what is the history of EEG and EEG-based biometrics? In 1924, Hans Berger records the first human EEG and discovers the actually alpha rhythm. So in 1930s to 1950s, there are actually adaptation of EEG for the disease diagnosis, like an epileptic seizure. I have actually earlier said, to identify that or actually to discriminate the different types of seizures, or to actually localize where this actually seizure is originating from the brain, or actually to predict the seizure. So if an actually seizure patient is actually diagnosed, the next time when the seizure maybe actually occurs, so for those we can actually they have actually started using EEG. And also to diagnose the neurological diagnosis, schizophrenia or an actually Alzheimer's or an actually Parkinson's disease. In order to diagnose these neurological diseases, also EEG has been actually started to use. So in 1970s to 80s, so the cognitive neuroscience links like EEG rhythms for attention, memory, and consciousness. In order to actually study these, also EEG has been used to. So means to understand the function of the brain. So to understand the structure of the brain, we may actually require to image the brain, maybe actually in CT or an actually MRI helps. But in order to actually study the function of the brain, how the brain actually behaves in order to actually doing attention when you are actually focusing on something. So how actually our brain actually memorize the things, the consciousness. So for this actually, in order to understand the brain, so EEG has been actually used. In 1990s to 2000s, so EEG has been actually used to actually study the during the task. So when we are actually watching an actually video, or when we are actually hearing actually some sound or an actually song, that is auditory stimuli, or an actually visual stimuli, or when we are actually moving the hands, that is actually the motor stimuli, or when we are actually having some sensory, maybe cold or actually in heat. So how actually our brain actually behaves. So for these actually also actually the EEG has been used. So in 2010 and 2020, we have actually had a lot of computational facilities, and this makes the arrival of different machine learning and deep learning algorithms, though may can actually easily understand the patterns in the EEG signal and also can actually automate the process. So in 2020s, foundation models were actually arrived. So what is foundation models? They are actually CNN models. Usually when we are using a CNN model, so we sometimes we need to actually configure our CNN models, or otherwise we have actually the ResNet or actually an other models. So they may be actually used to some other applications. So they may be actually trained AlexNet. So those models were trained in some other images, maybe actually car images or maybe actually satellite images for some specific application, and we are adopting that models to our actually application. So they may not be actually working well. So, however, if you can actually use foundation models, so these models may be actually dedicatedly trained for EEG signals. So, if you are adopting that models, our actually performance may be actually increases. So, how we can actually understand EEG and actually brain from ancient view. So manas are actually mind. So this is already actually well discussed in our actually ancient Puranas. So it is the process of sensory inputs, thoughts, or actually emotions of the inner coordinator. So in actually Puranas or Vedas, this has been actually well explained. So in our modern neuroscience, it has been actually explained as a working memory or an actually attention control integration of sensory input and decision making readiness. So the next one is chitta or actually the storehouse of impressions. So in philosophy or Vedas, the repository of past experiences or actually subconscious memory is called as actually in chitta. So the same in the modern neuroscience, it has been discussed in terms of long-term memory systems, like how hippocampus saves our actually memory and retrieves when it actually recurs. So the next one is actually the buddhi or actually intellect or actually discrimination. So it is the higher reasoning or actually judgment of actually discriminant discernment. So in the case of neuroscience, it is actually done by executive functions like prefrontal cortex functions like planning, inhibition, and actually problem solving. So Atman or actually soul, it is a well discussed like and the immutable essence of individuality and awareness. So in modern actually neuroscience, so it is actually the unique neural identity. So that we are actually adopting, like each person will be having its own actually specific soul or an actually neural patterns, whether this neural pattern can be used for actually biometric. So person specific brain dynamics that can be measured by an electroencephalogram, and those signals can be used as a biometric authentication or an actually identification. So, what is the motivation regarding our studies? So, we would have come across the Pathankot air-based attack by some militants. So, the insiders used forged ID cards. So, they have actually mimicked our military ID cards, physical ID cards. They have mimicked our military's uniforms, and actually they passed the checkpoints. So it resulted in multi-day lockdowns, submission delays, and actually loss of operational readiness. The next actually spoofing demo has been actually conducted. So researchers lifted a latent fingerprints from your glass and 3D printed models to fit smartphone users. So someone would have actually used an oxygen glass in order to drink the water. So their actually fingerprints may be actually in the glass. So they have actually taken this and they have actually printed earlier as I have actually discussed. They have maybe used some biomaterials and they have actually used to open this actually smartphone sensors. And also this actually voice cloning tools fooled the call center voice ID systems with a 90% success. You would have actually come across the movies, think Shivaji. So the people can actually mimic the voice of some other one. So I think Rajinikanth's voice maybe actually they are mimicking and try to actually open the systems. The cost of breach, the average breach cost is around $4.24 million and 280 days detect to contain IBM. So some kind of actually spoofing happened in IBM 2021. So it actually leads to loss of trust, safety risk, and regulatory fineness. So in this actually instance, our actually regular biometric models actually failed. That is maybe actually static traits, or that is fingerprint or face or hot copies of ID card, and also the environmental factors like wet fingers and poor lighting may also degrade our actually normal biometric accuracy. So in this case, as we discussed, we can use the neurophysio signals in order to actually increase the performance, and it may be actually true liveness and EEG uniquely tied to your brain electrical fingerprint. So why specifically EEG? So if you are actually alive, so only you'll be having the brain patterns. So EEG can give the direct measurement of brain activity and actually makes replay or spoof attacks far more difficult. So for different stimuli, different conditions, we have high uniqueness in EEG signals. So resting state will be having some uniqueness. Even related potential when you are giving some stimulus, it will be having actually some uniqueness. And it is actually person specific patterns. Another one is continuous and passive. So we can actually get continuous EEG signals when we are actually recording. So we can actually continuously authenticate without any delay. And resistant to external observation. So if you are actually thinking like only if you stimulate your brain, then you can actually open the biometric system. So no one can actually force to make that actually unique signal. So you can also actually combine these multimodals like EEG with other physiological signals or actually phase for higher security. So no idea of how many of you know about the EEG signals. So it is an summed postsynaptic potentials conducted through brain tissue and actually skull. We keep the electrodes on the surface of the brain, and then we'll be actually measuring this postsynaptic potential from the neurons. So once this signal is actually recorded, so if you decompose these EEG signals, so it will be having different frequency bands. So we call delta, that is actually the frequency from zero point 0.5 to 4 hertz, theta is 4 to 8 hertz, alpha 8 to 13 hertz, beta 13 to 30 hertz, and gamma greater than 30 hertz. So each signal may be actually dominating, or each frequency may be dominating on different conditions, like a gamma may be dominating when we are actually solving a problem, or if you are actually highly concentratedly doing something. So the gamma signal may be dominated in the signal, in the EEG signal. The beta may be actually dominated when you are actually in busy or actually in active mind, similar to gamma. So the alpha is reflective and restful. So when you are actually very actually rest, then alpha may be actually dominating. So the theta is actually drowsiness when you are actually feeling so tired. So you are not giving any work to your brain. So then the theta's frequency may be dominated in the EEG signal. So the delta is actually sleep and dreaming. So if you are actually studying the sleep through EEG signal, you can actually expect the signal frequency maybe in 4.5 to 4 hertz. That is actually the lower frequency band. Or if you are actually activating the brain, maybe through visual or auditory, or maybe actually some mathematical operations, then you can actually expect the EEG signal with a more gamma frequency. So the amplitude of these signals is in microvolt range from 10 to actually 100 microvolt. So we have seen the frequency from zero point 0.5 to maybe around 50 to 60 hertz. On the other hand, so its amplitude may be around 10 to 100 microvolt. So the spatial resolution is centimeter scale and improved with higher channel counts. So usually 20 channel signals or 32 channel EEGs are used. So you can actually use more EEG electrodes in order to get dense, high density EEG signals. So typically the sampling rate may be actually from 250 to 1000 hertz. However, it depends upon the EEG machine you are using. So now we are actually trying to see the hardware requirements for an EEG signal. So it requires an electrodes first. So what kind of electrodes we are actually using? So we are keeping these electrodes on the surface of the skull. So we can use two kind of electrodes, that is actually wet. So we need to actually apply some gel on the surface of the skull, and then we need to actually keep these actually electrodes. So this is called as actually an wet electrodes. The gel may be actually in gel. You can use gel or actually saline. So it actually helps to improve the conductivity. So it reduces the impedance, and these actually post-synaptic signals can be easily actually passed to the electrodes. Or you can use the dry electrodes. How? Because in the real-time applications, always to use gel on the surface of the skull may not be actually feasible. So you can actually use the dry electrodes, so no gel, faster setup and more comfortable and but higher impedance. So what is actually disadvantages over here is, so as there is actually no gel, so the conductivity may be actually less, so higher impedance may be actually there. So you may not be getting much information, or this electrode electrolyte interface, the much signal may not be actually passing, so it reduces actually the signal intensity. So this is with the electrodes. So now we can actually use the montages or channels. So in the last slide, I have actually discussed about the number of channels or the number of electrodes we can actually use. That is actually high density. We have actually discussed over here. So this depends upon the application, um, and how we can actually fix this actually electrodes on the surface of the skull. So that is called as actually the montage. So number of electrodes we are actually fixing is called as actually the channels, and where we are actually fixing this actually electrodes and how we are fixing these electrodes, it is called as actually the montages. Usually people use the 10-20 system for actually reproducibility. So what is actually the 10-20 system is actually they will actually first fix the nation, that is actually the front part of the head, so near the actually above the actually the nose, and then they will actually mark the inion, that is actually the back side of the rear side of the head, and then also they will actually fix this actually 2 years left and actually the right. So then they will actually measure this actually distance. Actually, the first actually maybe actually 10. So they will actually measure the total actually distance, measure the 20%, fix the electrode, then actually 10%, so again 10%, then 20%, then next to the 10%. So similarly from here they will actually fix the 10%, then actually 20%, then actually 20%. So of the total actually distance. So it is called as actually the 10-20 electrode actually system. So here we are again discussing about the channels. So how many number of actually channels we can actually use? So we that actually start from 2 to actually 128 channels we can actually use. So in real time, so using 128 actually channels or electrodes on the surface of the skull, no one actually maybe agrees. So if you want to make it in real time, you need to actually use two or actually single electrode system. So, however, if you use only actually two electrodes, maybe actually T3 and T5, you will be getting actually minimum information. So you need to actually compromise between the information and the comfortability when you are actually using the when you are actually recorded the data, and this the data should be actually passed through systems, EEG signals, acquired or analog signals. So you need to actually convert into digital signal in order to process in an embedded system or in computer. So you need an analog to digital converter. It should be actually greater than 16 bits in order to actually you have high sensitivity and actually good information passing. So the sampling rate may be actually greater than 250 hertz, and you might require a bandpass filter and notch filter within actually built in this embedded system in order, or actually an amplifier system in order to remove the noise. Maybe actually you will be having occurring with motion artifacts, the movement of the electrodes, or actually the noise surrounded by this other environments. You may be actually the signal may be combined with the noise. So such kind of actually noise can be removed by the bandpass filter, or actually they will be actually occurring with electric interferences because of the electric power line interferences, or actually other electric components in this room. So there is a possibility of 50 hertz power line interference, so that can be removed by an actually notch filter. So there are actually different kind of companies. They are providing EEGs. One is actually the Brain Products, Biosemi, G-Tech. So they are actually more like a research grade product, and consumer specific product like Muse, MO2 company are actually providing. So both wired and actually wireless EEGs are available. So wired may be actually by using USB or actually wireless through Bluetooth or Wi-Fi. So in the case of wet electrodes, so we are using the different kind of actually gels over here. So you can actually see over here in the wet electrodes. So electrode is over there and the gel. So this should be actually put on the surface of the skull. So then you have the stratum corneum, epidermis, and dermis actually layers in the skin. So you can actually either you can actually apply the gel on the surface of the skull, or actually some electrodes. We have possibility of having actually gel in the electrodes itself. So the size of this electrode is from to actually centimeter. So there is actually another kind of electrode that is actually not fall within the wet or actually dry. So we call it actually semi-dry. So electrode and the saline solution will be actually using. So that also actually you can actually see over here. And we have actually used dry contact electrodes. So there is no gel. So electrode is actually fixed on the surface of the skin. So between electrode and stratus corneum, there is actually no gel is applied. So dry non-contact electrodes. So electrodes then will be having actually an insulator. So that actually comes with the electrodes itself, and you can actually use it. So when we have the micro needle electrodes, so these electrodes are little invasive. We are actually applying these actually electrodes on the stratum corneum. So it actually goes up to the stratum corneum. So it is actually kind of an invasive kind. So it is not actually we are opening the skull and keeping the electrodes on the brain like an electrocorticogram, we call it as. However, it is not like that. However, it is kind of needle electrodes. So we are actually injecting on the skin. So it goes up to the stratum corneum. So see the size is actually nanometer to actually micrometer. So you will be getting actually more sensitivity, and spatial resolution also may be actually higher. So how you can actually choose the data electrodes. So wet electrodes, you will be getting cleaner data. So however, dry electrodes you can actually use for better UX. And maintenance is gel replenishment and versus electrode we need to actually consider. So once you have an actually electrodes, you have decided the electrodes, which electrodes you want to actually use, and you have actually decided how many channels of or how many electrodes you are going to use, and also you have actually chosen the montages. So in the case of montages, I said actually 10-20 system. So similarly, we have actually 5-10 system, 5-5 system, then they may be actually measuring 5% of the distance, and then 5% of the distance, and then they keep the electrodes, or 5% first, then 10%, then 5%. So different kind of montages are there. So general montages is actually 10-20 system. So these are actually typically based upon your application. You can actually choose it. So once you have actually chosen these electrodes and montages and the number of electrodes you are going to use, so you need to record the EEG signals. So you have actually also decided what kind of ADC you are going to use, what kind of amplifier you are going to use. So now you need to actually start recording the data. So in the case of recording the data, we have earlier discussed like you can actually record the data at the resting state. That is actually simply eyes open or eyes closed condition, and then you can actually record the data, or you can actually give some stimulus to the subject. So you can actually ask the subject or the participant to see some videos, or you can actually play songs, or ask the subject to actually move the hands and legs like the motor movements, or you can actually ask the subject to actually in an actually in cold water to actually feel the sensory, or actually in small amount of actually heat. So or actually the tactile, you can actually ask the subject to actually feel actually different kind of smells, olfactory, or actually the tactile like actually different kind of taste, and then you can actually record the signal, or you can actually ask the subject to actually do some calculation in order to actually activate their cognitive memory, or you can actually ask the subject to actually memorize some words and retrieve these actually words or numbers in order to actually activate their actually memory cortex. So these are actually called as actually paradigms. So these paradigms are actually designed for based upon your application. So paradigms refers to the experimental setup or task protocol designed to evoke specific brain response. Which part of the brain you need to actually stimulate, you can actually use this paradigm. So what stimulus can be present, how often and when it actually appears, so what participant is expected to, so how each data is analyzed. So these all comes under actually paradigms. So in the case of paradigms, as I said, actually stimulus driven. So you are eliciting the brain through external cues by actually and visual actually signals or actually auditory, or you are actually asking the subject simply to actually sit eyes open or actually eyes closed condition. So active actually passive other names it actually user focus or engagement. So there is actually no explicit data gathered in the background. So the key trade-offs here actually accuracy versus usability. So you may be actually if you are not actually stimulating the brain resting state, you may not be getting much useful information. Uh, but if you are actually stimulating the brain, so the subject has to actually cooperate, and you may be actually subject get tired also. So these are actually the limitations over here. So speed versus comfort also, subject may be actually undergo mental fatigue also. So there are actually different kind of paradigms. So the one is actually 300. So what this is actually there may be actually an blind actually screen may be actually over there, and suddenly actually a ball may be actually next one is actually steady state video work the potential. So we'll be asking the subject to see some videos that may be actually a happy video or actually scary video or whatever may be. So the subject actually sees the video. So visual cortex may be activated, and during this tenure, we will be recording the EEG signal. So next one is actually the resting state. The resting state may be actually eyes open or actually eyes closed condition. The subject has to actually simply sit and actually maybe keep eyes open or actually eyes closed condition. During this actually time, we can record the data. So next one is the motor imaginary. So subject has to actually think that he is moving his hand. So there are actually two motor-based recording. So one is actually that he is actually moving the hand or actually the leg. So during that time, we are actually recording the data. So that is actually the motor imagery. So visual imagery is actually the subject is imagining some visuals, maybe actually a pleasant actually visuals, or maybe actually the bad actually visuals. He will be actually thinking, so he is imaging in his brain. So during that we are actually recording the EEG data. So the next one is the steady state audio evoked potential. So this is like the subject will be actually making some noise or maybe actually songs or actually specific frequency of sound will be actually applying to his ear. So his auditory cortex may be activated, and during this time we will be recording the data. The next one is the memory. So we will be giving some arithmetic calculations, maybe 3 plus 4, 7. So he has to actually calculate, or maybe in the display it will be showing 2 into 6. So he will be actually calculating and actually 12. So during this time, when he is actually doing some, sorry, here arithmetic task is actually over here. So during this time, we'll be actually recording the data. So in the case of memory, so first actually in the display, the numbers will be actually giving like through to 5 and 8. So then it will be actually disappearing. So he has to memorize, and then he has to actually type in the keyboard. So 2, 5, and 8. So that is actually the memory task. So during this time, we'll be actually recording the data. So it is called as actually memory paradigm. Arithmetic paradigm we have actually discussed already. So also we can actually do hybrid combinations. You can actually do event related potential and the steady state video potential. and we can actually combine resting plus ML and also advanced feature spaces. We can actually use the Riemann geometry, microstate topographies. We can actually use the deep learning and the self-supervised learning algorithms. And you can actually use next generation modalities. So as I said, actually nowadays the single EEG electrodes is actually into the picture on the market because no subject will be ready to use these 32 actually electrodes on the brain or in the skull. So, however, if we can actually use a single electrode on the beside the ear, like an actually an headset, so then it will be actually useful. So, an ear and around the ear forms the factors for obstructive capture of the EEG signals. So once you got an EEG signals, so you need to actually pre-process the signals. So you can actually apply an bandpass filter. The usual frequency ranges from actually 0.5 to 40 Hz. However, it depends upon the application. It may actually vary. Sometimes if you want to actually study the sleep, only you can actually use 0.5 to actually 4 Hz. Or if you want to actually study about a high activation during some arithmetic calculations, you can actually use maybe actually 30 to 40 hertz bandpass filter. So if you are actually crossing these 40 hertz and if you're trying to study 50 hertz, 60 hertz actually signals, then you should actually use a notch filter because a power line interference will be always there in the EEG signal. So in India, it is actually 50 hertz frequency power line. So you need to apply 50 hertz notch filter in overseas. Maybe it is actually 60 hertz. So if you are actually using some online database that may be recorded in Europe or some other countries, so their power line actually frequency may be 60 hertz. So you need to actually use an 60 hertz notch filter. So in addition to these actually noises, there may be actually an power blink, eye blink noises. Maybe actually during the recording, the subject may be actually moving his actually eyebrows, so it may leads to noise. And actually the muscles, he may be actually chewing. So because of that, there may be actually noise. His actually heartbeat and respiration may also affect this actually EEG signals. So these noises will be also actually accompanied with the EEG signals. You can actually apply independent common analysis, regression models, channel interpolations, maybe actually some channels may be actually electrode off may be actually happen. So the gel may be actually removed. So the contact between the electrode and the skull surface may be actually poor. So it may leads to actually poor recording of the signals. So that times so that specific channel information we need to actually avoid, or we may be actually interpolate between these actually data points, and you can actually do this. So once this actually did this, then you can actually do the baseline correction by using z-scoring or min-max scaling. There are actually different normalization methods, min-max methods, or actually standard deviation and mean methods. Or you can actually apply this actually PCA and CSP to reduce the channels. So you may not be even you actually recorded 32 channel information. You may not be actually require all the channel, or actually you want to use in real time and you don't have much computational embedded system. You can reduce the channel information by using PCA and select the channels, and then you can actually go for the processing. So once you have actually did this pre-processing, you can actually segment the data. You would have actually recorded for resting state, maybe actually other tasks. So each task corresponding each signal you can actually segment, and then you can actually subtract with the baseline and actually normalize. And actually you can reject the epochs exceeding amplitudes. Still, if you feel some noise is there, and you can actually monitor the impedance and noise levels in real time. So once the signal is actually ready, you need to actually extract the patterns from the signal. So there are different methods for extracting the patterns. You can actually extract the signals from the time domain. So you have different features like peak amplitude, George parameters, statistical moments, zero crossing rate, temporal correlation, mean, standard deviation, skewness, kurtosis. All these actually you can actually use. So in the case of frequency domain, you can actually convert the signal into frequency bands. We have actually discussed alpha, beta, delta, gamma bands. And then in each band, you can actually compute the band powers, and also you can actually use the band power ratio, that is actually band power of theta divided by alpha. And also you can actually calculate the entropy and frequency ratios of these actually signals. In the case of spatial domain, you can actually convert the signals into spatial patterns and Riemann geometry and covariances and topographic variances. You can actually compute as a feature. So in the case of time domain, you can actually measure the features in the time, and in the case of frequency, you can actually measure the information in the frequency. So in the case of time frequency domain, you can actually measure the information in time and frequency. So there are different methods for this. There is actually wavelet transform, continuous wavelet transform, discrete wavelet transform, short time Fourier transform, Hilbert transform. There are n number of methods are there. You can actually convert into frequency, time frequency spectrograms, and from the spectrograms, you can actually extract the features. There are nonlinear complexity features like approximate entropy, sample entropy, permutation entropy, fractal dimension, etc. And also, you have actually connectivity network. You can actually calculate the connectivity between the channels. You can use the correlation. Then from the correlation, you can actually use the graph geometric metrics, etc. So you can also use the source space like independent component analysis and dipole localization and source reconstruction methods. So this is actually same as the earlier one we have actually discussed. So once you extract the patterns, if you want to automate this process, you can actually use the machine learning classifiers. So there are linear models like actually LDA, and you can also use SVM. You have linear SVM and the kernels based SVMs, radial basis function, polynomial function. There are different support vector machines are there. Then you can also use ensemble based methods. You can use some combine multiple actually classifiers, and you can build a model that may be actually boosting or actually bagging based method. Random forest is and bagging based method, and gradient boosting methods like boosting method methods are actually XC boost, ADA boost, etc. Or if you want to actually land the features automatically, so here we are extracting the features by using these domains. But however, if you want to actually, the model should land the features, you can use then deep learning models, CNNs or RNNs or actually SSTMs, LSTMs, attention networks, lot of actually models are there. So if you are using the either deep learning or actually machine learning models, you need to actually tune the parameters, you need to optimize the parameters, you need to actually generalize the model performance by using cross-validation methods. And the practical considerations are like interpretability versus actually the performance. So once you build the model, you need to evaluate the performance of the model. So in the case of general classification models, so there are actually different metrics as are like accuracy, sensitivity, specificity, precision, F1 score, ROC. So these are actually regular machine learning models to not evaluate the deep learning or machine learning models. In the case of classification, we are actually using. In the case of regression, we may be using R square, RMSD, so MSC. So those are actually in the case of regression we'll be using. So however, in the case of biometrics, we will be using some different metrics in order to actually evaluate the performance of the models, like actually false acceptance rate. So that is actually the how it is. Okay. False actually acceptance rate, that is the probability that an actually imposter is actually incorrectly accepted. So he is actually an imposter. So however actually the model is actually authenticating, then it is a false acceptance rate. So false rejection rates, he is a genuine user, so he is an actual user. However, he's actually when he is trying to authenticate, so he is actually rejected. So that is actually the false rejection rate. So equal error rate is actually the point where actually FAR is equal to FRR. So lower actually the better overall accuracy. So receiver operating characteristic curve. So plot of actually true positive versus actually false positive rate and area under the curve we can actually measure, and it can be used to evaluate the performance of the model. So detection error trade-off DET, so log scaled FAR versus FRR. So you can actually see over here. So it actually highlights the low error region. Through output and latency, so how much time it actually takes in order to actually authenticate. So that can be also used as a metric in order to evaluate the performance of the model. So we need to actually see about two more actually concepts like authentication versus identification. So in the case of authentication, it is actually one-to-one. So if we have actually verified actually claimed identity, and if we are actually trying to actually the system knows that actually it is Jack Fredo, and it actually try to actually match my identity with actually myself. So then it is actually authentication. Look, when you are actually putting your ATM card into the ATM machine, so it actually displays actually it is actually Jack Frodo. So when then what we need to do? So I need to actually enter my actually password. So this password it actually try to match with the already actually filed password of Jack Frodo, and it actually that's the process. So that is called as actually an authentication. So in the case of identification, the system doesn't know that it is actually Jack Frodo. So when you are actually giving the fingerprint into the system, so it actually searches all the actually users registered in the system, and it actually identifies that it is Jack Frodo, and then it is actually authenticating. So then it is called as section identification. So this authentication it is actually simple because actually verified claimed identity and determine in the case of identification determine an unknown identity from a group. So in the case of method, it is actually simple threshold decision because it is one-to-one matching. However, in the case identification, should actually match with all the actually users actually already enrolled in the system, and then it actually identifies. So it is actually a time consuming process. Obviously, authentication requires low computation load and identification requires higher computation. So in the case of actually authentication, capture one robust template per user. So in the case identification, build an identity actually and feature database for end users. So performance is actually optimize FAR divided by FRR trade-off, consider rank-based metrics and search latency. So in the case of application, secure login and continuous re-authentication. So in the case of identification, it is shared workstations, event entries, so group access on these kind of applications, we can use an identification. Some skill. So security and actually spoofing. So in the case of high security environments, you can actually use an EEG signals. So recording and replaying like some defense application in order to actually maybe activate an atom bomb or such kind of actually high level application you can actually use EEG. So there are actually maybe spoofing possibilities like recording and replaying EEG signals to fool the system. You can actually check the performance of the system. You can use fake electrode signals injected through and signal generators. There are actually now there are a lot of AI models that can actually generate the EEG signals. Maybe such models can actually mimic your EEG signals and adversarial machine learning crafting perturbations to feature space to mislead the classifiers. So these are how you can actually check the model performance. So countermeasures are challenge response protocols, randomized stimuli to ensure real-time response, liveness detection, monitor signal dynamics, multimodal fusion, combine EEG with the face or fingerprint and template protection, cancelable biometrics, and homomorphic encryption. So in the case of applications, so this can be actually used in authentication and actually security. And the case of military and space aerospace applications we can use. Or in the case of BCA, secure login we can actually use. In the case of banking and healthcare we can use. In the case of personalized AI system, we can actually use also in the education and the training programs, we can actually use some EEG-based biometric. So practical deployment challenges are environmental and motion artifacts. Definitely, when you are using any EEG signals, it may be actually affected by muscle artifacts, eye blinks, cable sway, and electromagnetic interference. And comfort and compliance, so headset weight, electrode preparation, session duration, these are all actually challenges in practical scenarios. And we need to actually calibrate our system because our EEG signals may be vary with respect to age. So maybe actually every month or in 6 months or 2 months, we need to calibrate the system. And hardware constraints, the battery life and wireless bandwidth, actually also the problems and privacy and regulatory concern and data ownership. And you need to actually follow the GDPR biometric laws also. Scalability and maintenance, managing large template databases and periodic re-enrollment. So this looks like currently not feasible. So however, maybe in future, so maybe actually wearable EEG electrodes may be actually coming. So on those days, these can be actually used to. So maybe actually when computer was invented, it is actually in bulk room actually required in order to actually keep this hardware. So now actually in an actually finger or an actually few centimeters we have the processing unit. So maybe currently EEG based biometrics looks not feasible. However, in another 10, 20 years, maybe we'll be coming with different kind of wearables, EEG based wearables. So at that time it may be actually possible. You can actually also go with the hybrid biometrics combining EEG, ECG, and eye tracking, and quantum and neuromorphic AI integrations. We can actually use neuro privacy and legal frameworks we need to consider, and brain-based passwords. Maybe actually the Neuralink and Elon Musk company is actually trying to implant the electrodes on the brain, and in the future we may not require to actually communicate orally. Maybe brain to brain, we may actually communicate. We can actually send messages from brain to brain through electrodes implanted on the brain. On those actually days, maybe actually this may be one of the method in order to authenticate your actually system, or actually to send the messages, or actually to receive the messages. Who knows? Maybe actually it may happen. So I'm going to actually the next phase, like one of the study conducted in my lab. So we actually recorded the EEG signals in our lab and we conducted some experiments. So that I'm trying to actually explain in another actually 10-15 minutes. So in this study, we have recruited 27 participants. So we have actually 15 males and actually 12 females. And we had actually most of them are right-handed and one is actually biased. And we have the age range from 24 to actually plus or minus 5 years. And there is the mean age, and we ensured that the subset doesn't have alcohol, tobacco, or drug consumers, and there doesn't have any sleep disturbance or insomnia, and there doesn't have any diagnosis of psychological disorders or actually an epilepsy, and there doesn't have any learning disability or enrollment in special education actually classes. So these are the inclusion and exclusion criteria we followed in the study. So I have actually discussed about different actually stimulus. In our study, we have recorded the data in eyes open condition, steady state video walked potential. So the checkerboard patterns we show in the screen. So these checkerboard patterns may be actually varying at 5 hertz, 8 hertz, 12 hertz, and actually 15 hertz. So similarly, we'll be actually applying the sound that is steady state audio walked potential at 20 hertz and actually 40 hertz. So we have also stimulated the brain using actually motor. So the left hand actually opening and closing of the fingers. So we have also did actually arithmetic during that condition. Also, we have recorded the data. Similarly, in the case of actually memory, we display the numbers on the screen and it actually disappears, and the subject has to actually retrieve these actually numbers in the order. So there is memory task also we have done. In between each task, we have also actually did the eyes closed condition in order to actually get the baseline. So the baseline is recorded before all tasks except the eyes open task. You can actually see over here the multi-paradigm fusion for task-independent EEG-based biometric authentication. So we have actually given the different stimulus. The one of the subject, my student is sitting over here. So he is wearing an EEG cap with electrodes. 32 electrodes are over there, and then it is actually from here to amplifier. It is actually wired. From the amplifier to the system, it is actually wireless. You can actually see over here the instructions. So this is actually a motor hand stimulation, that is he needs to actually close and open is actually the fingers. So we have actually received the signal. We actually did the pre-processing, removing the noises, and then we have actually segmented the EEG signal corresponding each actually stimulus. So the signal duration we recorded for eyes open, steady state video worked, or steady state audio worked, eyes closed, motor, arithmetic, etc. So once we have actually segmented the signal, we computed the features from each segment, time domain features, frequency domain features, time frequency, and nonlinear features we have actually extracted. And these we unified this actually feature set, and we have actually recorded two sessions from each subject, two times actually recorded. Session one also we completed with all these paradigms. Session two also we completed with all these paradigms. And we actually trained our model by using data obtained using actually session one. And we tested this actually performance of the model from each subject. We have actually in session two also. That data we have actually used to actually test the performance of the model. So here is the few actually results. So we have actually plotted the comparative analysis of unified multi-paradigm model versus single paradigm model. So when we are actually combined these actually features from different models, how this actually model actually performs, and we have actually built the actually model with actually single paradigm, how the model actually performances. And we have actually used the equal error rate in order to access the performance of the model. And we have actually different classifiers. This is actually a template-based actually machine learning model. Here is the random forest results. Here is the logistic regression. Here is the support vector machine, and here is actually an 1D CNN. So the measure actually we consider is actually an EER rate as an actually an equal error rate is used to evaluate the performance of the model. So consistency superiority, the multi-domain paradigm fusion model consistently achieved the lower error equal error rate across almost all tasks compared to single paradigms. You can actually see over here. The red one is actually the single paradigm and the blue one is actually the multi-paradigm. So you can actually see where the color rate should be actually lower. So blue one is actually more, all the actually paradigms actually the lower. That is actually when we built the model using multiple paradigm, so the model performance better. So when compared to a single paradigm, so this can we can actually see in all these actually machine learning models. So greater impact on weaker tasks. The performance improvement was most dramatic for tasks which that are essentially challenging for an excellent single models. So you can actually see over here in the case of actually which paradigm is actually performing well. In the case of steady state video worked potential, you can actually see actually the lower error rate and the higher error rate is actually you can see over here in the case of actually eyes open and actually condition. So that means when you are stimulating the brain, so use an actually biometric model. So in the case of LR model, so it actually uh, it performance well, its performance is well, and also the SVM model is also performing well. So in the case of actually deep learning, the model's performance on difficult non-evoked tasks improved substantially. So, however, when overall LR actually performance well. So here is actually an accuracy, precision, recall, F1 score, and EER for actually the support vector machine model and random forest logistic regression and actually the 1D CNN you can actually see over here. So the other metrics also we computed. And you can actually see over here, we achieved up to actually around 99.08 actually percentage of accuracy. And the error rate is actually around actually 0.60. That is actually the lowest in ALR. So also accuracy is and the case of logistic regression around 99.84. So our model says, our research says that is actually performing well. So clear performance hierarchy emerges in LR and SVM. And top tier models show stability also, and you can actually see the better performance. So we can also see the performance of AI models with respect to different actually features. So as I said, we computed the time domain features, frequency domain features, time frequency domain features, and non-linear actually features also over here. So the x-axis is the performance, accuracy, so precision recall, and F1 score. And the y-axis is actually the feature actually. So when we are actually combining the features, that is the multi-domain features, we will be getting actually better performance when compared to actually a single domain actually features. So that is our actually observation over here. The conclusion of our study is so we have successfully developed a multimodal, multi-paradigm fusion pipeline that overcomes the critical issues of session variability and paradigm dependence in EEG metrics. The key finding is actually in simple, interpretable logistic regression performs better than actually in complex one-D CNN. And the top performance winning LR model achieved around an F1 score of 95.46 and a lower recall error rate of 2.1. So this work significantly advances the potential for creating secure, robust, and reliable EEG-based authentication systems. So the limitation is actually we don't have an actually large enough data set. We have actually recorded 27 subject, out of which 25 we have used for analysis because two subjects data was actually not good quality, and we have actually recorded this in high controlled environment, which may not be actually mimic the real-time scenarios. So manual feature engineering, we computed the features like in time frequency and time frequency domain. These features we can also fed the signals to the CNN models, and the we can allow the models to actually extract the features. So in future, we'll be combining different larger data sets and more diverse data set and longitudinal data sets we can actually use. So we can think about how we can actually fix in real time, and also we can automate this actually feature extraction using deep learning algorithms, and we can actually enhance the practicality and the security. So we would like to thank the DRDO Defense Research and Development Organization. They funded around 70 lakhs of rupees in order to perform this research. We have equipments and consumables. Everything is actually purchased through this actually project. Life Science Research Board of DRDO. So we would like to thank the funding agency, and here is our actually the team. So we have an actually around 15 members in our 15 to 20 members in our team. So thanks to all the PhD scholars, MTech, and IDD, so those who actually helped in order to actually perform this task. Thank you. So yeah, that's all my talk is. So if someone has any questions, we can actually discuss.
Thank you very much, sir. Dear participants, if you have any questions, kindly unmute yourself and ask the resource person.
Hi, sir.
Yes,
May I have a question?
yes, please.
That this is Manindra Rangasamy from Meera Single Engineering College. Sir, so what you said is phenomenal, and we are actually manifesting some results that is we are working on. So my question is, so the moment you say a lot of the support system you are making for researchers, scholars, and who really want to help. So, oh, can you please elaborate the pipeline or bridge that it can be connected officially if we want to work together, maybe with a organization or like a startup?
Can you come again? So I think there is some communication problem over here.
Sorry,
So
sir.
can you come again? So what you're saying, like translation
Sir,
research you're talking about, or collaboration you're talking about?
the collaboration, sir. So maybe the moment you can extend a support system from
Hello. Hello. Even you can actually type the question. Like I think.
biomedical device had a research, and even my students who a lot of people working, but the problem, we thought of having a one expert opinion anytime, maybe we can bridge and we can connect in future. So we just required an support system. Will it possible either way that IT is providing us, sir?
So which institute you're on? Where are you from?
Maybe incubate something like that, maybe the moment we incubate something, so to the next level, maybe IT is supporting us in any other way with a scheme or a program that we I like to know, sir.
Yes, so we have our own research park in IIT. So there we can actually have our own startup. And we have an iHub, iDapt. You can actually search iHub in IIT BHU. So that always calls the projects and proposals in collaboration with IIT faculties for translation research. Apart from that, we always call the interns here during summer and winter. So during summer, so the students can actually come over there and stay in the hostels, and we can actually work together. And if something actually progressive, we can actually go for translation research. During winter, they need to actually stay outside because it is a short duration. So these are the feasibilities how we can actually work together and collaborate officially. So apart from this, always you can actually walk to our department. Always you can actually visit our lab, and we can actually work together. There is always we are open, not an issue.
That is very kind, sir. Thank you so much.
So you need to actually search for iHub, IDAPT, iHub, IITBHU. So there are a lot of possibilities like student project call is there, UGPG, they support, and even they actually support for the postdoc, they support for the doctoral programs, top up doctoral programs. So there are a lot of calls out there. So you can always check into that and apply on it.
Thank you so much, sir. That is very informative.
Yeah. Any other questions?
Dear participants, if you have any questions, kindly unmute yourself, ask the resource person.
If you don't have any questions, I can actually
Sir,
stop here.
I think no questions from participants side, sir. Shall we close the session, sir?
Yes. Thanks.
Thank you very much, sir, for your informative session on EEG.
So
Thank
yeah,
you very much.
so who is your HOD? Someone actually texted me. Some Dharmalingam, Dr. Dharmalingam.
Yes, sir. Yes, sir.
Okay. Okay.
Okay,
Okay.
sir.
Thanks.
Thank you, sir. Thank you.
Recording stopped.
Dear participants, feedback link is posted in the chat box. Kindly fill it. So tomorrow's session will be started 6 p.m. Kindly join on tomorrow. Thank you very much.
Sir, can I get the feedback form once again, sir? I'm not able to open my chat.